utility level. So your utility increases by buying more varieties from the outside country. Now for the foreigners the same thing happens. So there is trade in varieties, intra-industry trade. So now we have a basic model that is able to explain intra-industry trade. What is important here? Demand side, law of variety effect. It ensures that consumers consume all varieties and increasing returns to scale. Each variety, because of scale economies, is produced by only a single firm, and that firm has to be based either in the home country or in the foreign country. Now let's suppose it's based in the home country, then it will also sell, it will also export to the consumers in the foreign country because these consumers also love variety. Same thing happens for the foreign country, this is intra-industry trade. Yes?
So the
Utrecht, can you hear this?
yes. My question is, ultimately the number of varieties increase because the number of firms entering the market is larger than the ones leaving the market,
Yeah.
right?
And why is that? Because you suddenly are able to consume all the varieties that are produced in the foreign country using the labor amount of the foreign country.
And why is the
You can also put it differently. So given the fact, so let's return. Here's my scribbling. So the number of labor per variety is identical for all varieties. Now the total amount of labor increases, the LH, labor supply in the home country, plus the labor supply in the foreign country. So that is definitely an increase, a larger supply of labor. Given the fact that per variety the amount of labor is the same, I have total labor divided by L is N. What is L in the free trade situation? That's L in the home country plus L in the foreign country. So it definitely increases. Yeah? Does it answer your question?
Yes, thank you.
Okay, so far so good. Of course, as always happens, there are extensions. Now there's a law for variety effect. Bill Ether has become very famous because he basically made a very simple assumption. He says, well, this is the law for variety effect, but let's assume it doesn't apply to consumers, but to producers. So you have a production function, and the cost, the unit labor cost, decreases if you have more intermediate products that you can use. So it's the same idea, but now from the production side, the supply side. So not a law of variety effect from consumers, but a law of intermediate products for producers. Now, same idea, results in more or less the same type of models, but this is a typical extension. So all sorts of interesting extensions have been made. So, we're now left with graphite. There are no questions, also not from Utrecht? No? Okay. So now we are going to the graphite model. Now graphite is a very important model. So if you look at the data, now the Heckscher-Ohley model doesn't perform very well. The Ricardian model performs a little bit better from an empirical point of view, like we saw last week. The graphite model is a very famous empirical regularity. It relates straight to distance. And we like to derive the graphite model. Now what you see here is just an example. That is German trade with partner countries. And what you see here is that, for example, trade with the Netherlands is relatively high compared to trade with China, which is remarkable. Because China is a huge economy. Still, trade with the Netherlands, if you look at Germany, is bigger than trade with China. Now the graphite model explains this. The graphite model tells you that there is a relationship between the size of the two countries. So two big countries, France and Germany, they trade a lot with each other, and they trade more with each other if the distance is very small. And this is what you see here. So, small country, basically you expect not much trade. However, if the distance is very small, you expect relatively huge amount of trade. So it's a trade-off. Size and the trade-off is distance. Now distance is a very abstract concept. So distance is not only distance in kilometers, but it is also cultural distance, distance in institutions, all sorts of contractual frictions, customs differences, language differences, and these are all included. So if you talk about distance in the gravity model, basically what you assume and what you're talking about is not distance in kilometers, but you're talking about distance in an abstract way. So distance in tariffs. So if there's a high tariff, you expect less trade. Transportation cost, that is distance in kilometers. If you have to travel far, it costs a lot. Administrative hurdles, you have to translate your user manual, costs time, costs money. You have to involve lawyers to enter a foreign market. All those things contribute to distance. So distance is a very abstract idea. Now this is a very important empirical regularity. Now why is the monopolistic competition model so useful, and also the model of next week? That in the old days, the gravity model was invented by Jan Tinberg in 1962. He simply assumed, looking at Newton, the gravity model from physics, if you have two big planets, they attract unless the distance is large. Now, Jan Tinberg simply used this idea. He says, well, we have two big planets, and if the distance is small, they attract each other. Now, let's apply that to trade, and it was very useful. So, the gravity model became very popular. However, it became less popular in the 1970s and 80s because we didn't have a microeconomic foundation. So there was no theoretical model that could produce, in a convincing way, a gravity model. Now the monopolistic competition model turned out to be very, very useful to derive the gravity model. And that also increased the reputation of the gravity model. So we have an empirical regularity, works like a miracle, but we didn't have micro foundations. Now, Paul Krugman introduced the monopolistic competition model, based in essence to explain intra-industry trade, and it turned out that it was very, very useful also to explain and to motivate and give a microeconomic foundation for the gravity model. How does it work? Now, remember that we already derived, or something that we will derive next week, is the demand for a particular variety is a function of income, the price of that particular variety corrected for the price index of all other varieties. So this is the price index. It's a summation of all varieties in the market. Let's rewrite this equation for bilateral trade. So it's not trade from country I to the rest of the world, but it is trade from country I to a particular country J. Same idea, price of that commodity I to a market J. Well, what is the price in that particular market of your variety? That's Pij. What is the price index that is relevant for you? Well, it's the price index of all competing commodities in that destination market, and you sell to all the consumers in market J. So this is the demand function. Same idea, monopolistic competition, but now rewritten for bilateral trade. Yeah? And the price index, of course, has to be adapted. How can we derive a gravity model? Now, 6 steps. So we can derive the gravity model in 6 easy steps. So let's go over each of these steps. And I think the slides are already posted on Nestor. My derivation is a bit more transparent than the derivation given in a textbook from Anderson and Winko. That's something for you to find out. Anderson and Winko discussed in Veenstra, perfectly fine derivation. I think this derivation is a little bit more straightforward. Gives the same result. Now the first step is, what is the value of a particular variety originating from country I to country G. That's simply the price times the volume of sales. Now let's assume that the share that I as a country have in the demand of the destination country is this particular share, SIG. So what is the volume, the value of this flow? It is simply how important I am in the income of my destination country. I have a share SIJ in the income of the destination country. And that's by definition equal to the value of the flow to the destination country, originating from my country. What do I already have? I already have the demand side. That was my rewritten monopolistic competition demand side. It was the bilateral version of the demand from monopolistic competition. So that was already given based on utility maximization subject to an income constraint. I can simply plug that in. So what is the share of me in the income of the destination country? That's simply the value of this flow divided by that income. Now, return to this equation. I can simply multiply this by Pij divided by the income of the destination country and derive an expression like this. So I have perfectly valid derivation of the share of me, I, in the destination country J, where again the price index is defined as this. If there are questions, let me know. Step number 3, distance. Now, you have all these distance effects. What does it mean? In its most basic form, it means that my price, so what I sell to country J, has to be multiplied by transportation cost. Now, you can include anything. Language differences, institutional differences, distance in kilometers, anything that contributes to making my price larger in the destination market. So the further away the destination market is, the larger the T, the larger the price in the destination market. So Pi is the price at the door of the factory, multiplied by the transportation cost to a particular destination market, is the price in the destination market. And it includes the basic fact of the gravity model. It includes distance. Total trade flow. Now I have the trade flow of a single, the value of trade of a single variety, but what I'm producing is Ni varieties. So my total trade flow, the value of my total trade flow, is the value of each individual trade flow multiplied by the number of varieties I'm producing. Now all these varieties are the same, at the same price, that's the setup of the model, and plugging all these aspects in, Pi, the value can be rewritten in terms of the share of me in the destination country times Ej. So that's derived from here. A little algebra gives me this, and we use this particular expression. So now I have an expression that relates my total trade flow to